Okay, so the example I'm going to do today is the same one I did when I introduced Coppelia Sim. I talked about how to simulate a projectile with drag, and this time what we'll do is we'll do this through MATLAB. Okay, and so there are really two ways to set. So the way this works is you create the object or model in Coppelia Sim, you run the simulation. You run the simulation in Coppelia Sim first, and then you call it in MATLAB, and you see how that goes. Uh, when you start a simulation in Coppelia Sim, it just keeps running, and then if you don't call MATLAB fast enough, then you'll see that you can't do much. And so there are ways in which you can initialize the simulation Coppelia Sim, and two ways to do that are set gravity and add force torque. I will show you one of them, which is set gravity. There are commands in uh, Coppelia Sim commands which can be called from MATLAB. There's a separate API for that. I'll show that API too. And so those scripts, some of the commands which you'll be using, I've listed over here, and I'll show you how they are used and as they're used. Okay, so find the Coppelia Sim MATLAB API. Okay, so this I'm going to share this link through chat. Okay, so this is a remote API in MATLAB. Okay, so for example, one of the commands we've been using a lot is get object handle, right? So let's search for that. Object handle. So it's get object handle. So here is the get object handle. So when you use this in Coppelia Sim, you call it as sim.getObjectHandle. When you use it in MATLAB, you'll be calling it as simx get object handle. Not much difference, right? So the commands are slightly different. I want you to know that. So you can bookmark the page I just sent. You'll be useful when we start writing commands. Now, the other thing you want to have with you, and I'm going to share this, sort of send it to you via chat, is I've made a template folder for Coppelia Sim. You'll always start off from that template folder. Okay, first let me send it via chat. Okay, I'm going to send it now. So that's MATLAB. This. Okay, I send it. You should have received it. And let me show you what that looks like. So this is the template I sent. The template has these files. You should just keep them as it is. Uh, I think depending on your OS, you might have to change this file. So I took the Mac one, dylab live, which I put over here. If you're using a Windows system, you want to take this particular DLL and put it over here. Okay, and same for Ubuntu. So just keep that in mind. These two files you will not modify. Let me open them up for you. Okay, so here is rem api.m, and then here is proto.m. You can skim through this. I don't think you really need to know what is there right now, but don't modify those. This is the template file which you will edit. So this is the file we'll be editing and modifying it to suit our purpose. Uh, I've put down the place where you will put code. If you want to run a code non-stop, you will put a while loop, and you will have an end, and it just keep running forever. If you want to stop it for something, you can just stop it. But essentially everything else has been done for you. You just have to write code here. Okay, and these files came from Coppelia Sim. Okay, this is about how the connection between Coppelia Sim and MATLAB work. It basically is a server client type of framework where the Coppelia Sim is the server, is broadcasting messages, and the client is MATLAB, it's receiving those messages, and you don't have to worry so much about how these things work. Only thing you need to do is write code over here. Okay, and then the third piece is basically this TTT file. I just put TTT file here. That is You can put the TTT file wherever you want, but I just would always, it's nice to have all your TTT files corresponding to this MATLAB file in the same place. So what you do is you make your TTT file, put it over here. Um, you need to do a bunch of things, which I will show you as we proceed. The example I'm going to use is from, as I said, from the first class where we talked about Coppelia sim. So let's just take this file and I'm going to paste it here. This is my, let me make a copy of this. This is my original file. Okay, I'm going to rename this and let's call this projectile main. So now this will be modified so that it works with this projectile file. This is my original file, which I just keep here for my reference. So let's open that and just refresh what we did when we did this projectile problem, right? So when you run this, you see that the ball jumps and it comes to a stop somewhere, right? And then we also wrote some code here. If you look at the code, we basically set the speed in the X and Z direction. We got the position, and then we also got the velocity, and then we introduced a drag force using add force torque. Okay, so we are trying to do this same thing using MATLAB. Okay, that's my goal. So this is my original file. I'll keep it as it is. So as a reference, I'm going to open the projectile.ttt file, which I had made a copy of. And here, let's just comment out everything. I don't need anything of this. Okay, so if you run this now, you see that it falls. Okay, now, so let's go to this file which I wrote down. Okay, so we did that. We put the TTT file in this folder. Right, so we put the TTT. So the step one, we put the TTT file right here, projectile.ttt. Then put this command either in the child script init function or in the main script. So two places to put it. We just want this thing to be called first. So you can either put it here, sim.remote start, or you can do is you can go here, main function, and then put it right here in it. That should also work fine. Just put it in one place, okay? So don't put it in both places. Did that. Next, run the Coppelia sim. Okay, so that's just saying that take this and run this. And then what you need to do is to get anything to work, you need to, without stopping 3, that is without stopping Coppelia sim, run the MATLAB file. So now if you go to MATLAB, if you run this, it's going to execute. Okay. Okay, that's because I renamed it. Let me just stop, close this. And then this is my projectile. Okay, so it's still running. You can see it's not stopped. It's still running. The time is going. I keep the MATLAB file open. I run this. Okay, so it's just started and ended. So it didn't do anything because there's no code here. But that it communicated with this. Now the issue you can see here is that if you want the ball to start from that position and then fall down, then this doesn't serve the purpose because it already fell down. And then when I go to MATLAB, it already had fallen down onto the ground. So this is not working. So what I recommend doing in this case is to go to dynamics and then just change the gravity to 0. There are other ways to do it. You can add force torque to start it. You could also reset the dynamic simulation, but let's not do those things. Let's just put that to 0. I think I should do it after it's stopped. Okay, it's working. Okay, so now if you start it, nothing happens, right? Now if you run the MATLAB file, nothing will happen either because nothing is there. Now what I'm going to do is, first thing first, I'm going to set gravity here. So let's go to the go over here and remind ourselves how to set the gravity. Sometimes it's very useful to see the actual manual for the regular API. Okay, so if I remember correctly, it was set array parameters what I think is used to set the gravity. We've done it in a previous class. So set array parameter, and the way this function works is you need to say set array parameter, parameter table, parameter values. So there should be an equivalent one here, like this in Coppelia in the API. Search. So there is an array parameter, and then this is how the syntax is. It's this. So client ID, that's the same client ID which you saw. Don't change that. Parameter identifier, param values, and operation mode. Okay, so let's copy this in MATLAB. Okay. So return code is just saying that it worked or didn't work. So you don't have to worry too much about that. We can also not call. We can just delete it altogether. Now all the functions should be called as sim.simx. Okay, remember that. The client ID is the same as the client, which is right here. So you don't modify that. We need the parameter identifier. So let's look at what the parameter we are looking for. Okay, so we're looking for gravity. So set array parameter gravity. This is the one we want. Okay. Let's check something. The issue is that this cannot be it because it should always start with simx. So we need to find the it should be something like sim underscore. So actually, if you can try to search for it in here, it actually links the. Let's see, is it? Yeah, so this gives you the parameters actually in the regular API, not the remote API, the MATLAB one. The remote one, the remote one can actually be found from this REM API. There should be something corresponding to gravity here, which looks very similar to what I just saw. So Control F, gravity. Let's ignore gravity. Okay, so this is what it should be. It should be this thing and not sim dot. So let's just take this and put it here. Okay, so always do sim dot sim array gravity, because this is an object which is created in the rem api.m, and then that's the value. Then param value. So we want to put, in this case, gravity equals to 0 for the x, 0 for the y, minus 9.81 for the z. Okay, and the last thing is the operation mode. And for this, we need to go back to here, set array parameter, and look at the operation mode they recommend. Here is the operation mode. The recommended operation mode for this function. So they give you the operation mode which they want you to put. So take that simx of mode one shot, and you can read more about operation modes here. There are these multiple option modes. The common one is one shot, which is basically you send the command from MATLAB to Coppelia sim, but don't wait for a reply. The other one, which is the blocking one, which is you send a message and you wait for it to be received. That the information is sent back to MATLAB that was received by Coppelia sim. I don't think you need to worry too much about it. Just be aware that what they do, and they recommend what needs to be done. So we take that, put it over here. Okay, and as once we are ready with this, let's comment this. We again do the same thing. We stop this. Okay, it stopped. Now start it, and nothing happens because gravity is set to 0. Now let's run the MATLAB code, and let me actually put it in such a way that you can see both the windows. Okay, so here I am running this. Okay, so it looks like the gravity was not set. One way to check that is to go here and see if the The gravity was set, but it did not fall. The reason it did not fall is because once you set gravity, you need to refresh the physics or reset the dynamics, because you can't just switch on gravity suddenly. So there is something called resetting the dynamics, and that's what I'm going to do next. So that thing is it's called, let's see, let's go to the regular API, reset dynamic object. Okay, so once you set the gravity, you need to reset the dynamics or reset that object. In this case, the object is the sphere. Okay, so what I need to do is I need to set this up. Now, this is a command in Coppelia, same. We need to find that in MATLAB. So we can try to search for this. Go back. Okay. I don't see it. Okay, so it's not here because you could have seen it here, but it's not there. See. Okay, so there's a problem then, right? We don't have a command which goes as simx reset dynamic. So the question is, how do you access a command which doesn't exist? So there is something called uh, child scripts. Okay, and child script is a way to emulate any command from the regular API from MATLAB. So if you go to child script, here simx call child script. Okay. Okay, let's see what this does. Okay, so this is a way in which you can emulate any command in Coppelia Sim. If it doesn't exist in the MATLAB API, you can create the function for yourself. The way this works is the following. You would take this sim call script function syntax, which is right here, put it in MATLAB, and you can call that function. In this case, it's reset dynamic. So I'll call my own user set reset dynamic object function in MATLAB. Then I will write an equivalent function in Coppelia Sim, and that will be whatever my function name is. So that's, say it was my user defined reset dynamic object. I'll define that and it'll do what I need to do, and then MATLAB will call. So this is how it goes. So in this case, I'm trying to write my own reset dynamic object to be called from MATLAB. So first thing, I take this MATLAB synopsis. I put that in MATLAB. Okay, there's too many things here. Let's see. The return code, I don't care about the return code. Outins, outfloats, these are outputs produced from that. These are user-defined outputs. So I just keep them as it is. We don't worry about it right now. We don't have to set any of these things. Now call x script, this is should be called simx call script. Client ID is the same as what we have already defined. Script description. So this is going to be the name of the scene object the script is attached to. Okay, so this script is attached to, in this case, sphere. So we need to put a sphere there. So let's go back to MATLAB and change that to, should be single quotes. Okay, and then number, script, handle, or type. Okay, so what's this? Let's see the. Okay, so this is the script to which it is attached to. So there are three types. So there is the main script, which I showed you earlier, where we put the sim start. I showed you where to put that, but we're not writing that. We're writing it in the child script. So it will be a child script. So we need to write that correspond to a child script. So we need to take this thing here and paste it there. And again, you need to put sim dot. Okay. Okay, then function name. So this is my user defined function. So I'll call that, just to be clear that I have all these user defined function, I'll always abbreviate my files, which I create as user defined reset dynamic object. So it's very easy to recognize that this function is something I wrote. Okay. Then ints the input arrays. Okay, now in this case, are you passing in any variables? Here you're not passing any variables, so I'm just going to put nothing, floats, nothing, input strings, nothing, buffer, nothing. And then operation mode, we look here for the operation mode that is blocking. So let's take that, paste it here. Okay, and just stop this. Okay, if you want, you can call it a different name so it doesn't go right. Okay, so I have now written the function call from MATLAB. I still need to define it in Coppelia sim. So I need to define my own user define this particular function, and it should basically reset the object. So let's go back to Coppelia sim, open sphere, and then the question is, where do we put it? Well, you put it as a separate function. So function user define object, and then end it. And then all it does is it emulates this reset dynamic object. So we take this, so the C1, this one, okay, and go here and then paste it. And then it requires the handle. So let's just get the handle up over here. So we can say sphere equals sim.get object handle sphere. Okay, and now this is the one which I'm going to reset. So it goes here. So what's going to happen now is when I run this, it will basically do nothing. Then it will go to MATLAB. In MATLAB, we'll first call set gravity to 0, 0, minus 9.81, and then it will call this function, and it will basically call this user reset dynamic object, which will go here, get into this one and reset that. Okay, that's all it will do. Now, before I start this, let's go and check this gravity. It should still be 9.81. So let's just put 0 here. Okay, so checks. Run this, nothing happens. Go to MATLAB. The way it fell down. So it fell down because now it not only set the gravity, it also reset the dynamics. Now, what happens here is that when I stop this, okay, and I stop this and I go back to here, gravity is set to 9.81. So now when I restart the simulation, it'll fall down without me turning on the MATLAB code, right? So that's not going to help me because now, again, I need to go and set that to 0. So why not just set that in code? So what you can do here is, let's stop this. Okay. Let's set this back to 0. Okay, and then let's go right in the code. And just like we called this in the beginning, right? Just when handy, before it exits the code, we just go here and then just say that we want to reset the gravity to 0. So every time it ends this code script, it just set it back to 0, and we don't have to keep setting it back to 0 in the GUI. Okay, so let's see how this works fine. So I set it here, saved it. Now gravity is set to 0, which is good. When I run this, it doesn't fall. Let's go to MATLAB, run. The ball falls. That's interesting. And then the gravity is 0. Okay, it's set to 0 because of that. Now you saw that it actually in midair it basically stopped, and that's because this program here basically just executed. It didn't really wait long enough for the ball to hit the ground. So if you want to do that in MATLAB, what you can do is you can use tick Tick basically sets the timer. So we just say t start equal tick. So the moment I click, it starts from 0. And then let's say the total time is 4 seconds. I want to run it for 4 seconds, which I deem to be long enough for this ball to hit the floor. And then what I can do is I can run an infinite while loop first. Just keeps going and just doesn't quit. But what I can do here is I can say if talk is when you want to end the timer, t start greater than total. That is just saying that once time becomes more than total, which is 4 seconds, what you need to do is you need to break this while loop. Okay, and then it will wait for 4 seconds, break that loop, and then we'll all be fine in terms of it not stopping in midair. So let's save this, run this. Now it's nicely waiting for us to start this MATLAB code. Start the MATLAB code. It fell down. And then you can see it's still waiting. Now it ended. So it took 4 seconds, but the time it already did. Okay, now a few things we need to do now to finish this off. One is I need to set initial velocity in the XYZ direction as follows. And then I need to set the drag force. Okay, so let's see how to do that. So the way I like to do this is try to see what code you write in Lua and then try to see the counterpart in MATLAB. So in this case, I need to set a float parameter. Okay, so let's see if this function exists in MATLAB API. Okay, so that does exist. So I click on that, and then this is the syntax. Okay, so let me get that over here. Since it's initialization, I need to put it before the while loop. Okay, now let's start putting things there. So return code, just give it return code as 3. So I always need to call it as sim.simx because sim is the object in MATLAB. Then we have client ID, which is already defined. The object handle. So this is the object to which I'm going to assign this particular initial velocity. So in this object handle is right. Okay, I have not got the handle. Okay, so I need to get that. So before I do this, I need to get the object handle. So let's see where that is. Object handle. I said best to go here. Get object handle is what exists in API, regular API. So I search for this. Okay, so get object handle is this. So just copy this. So let's get the handle first. Okay, return code, number handle. So the return code you can put it's 0. Handle. Now this is the name of the handle. I'll just like to call it a sphere. Okay. Client ID is what it should be. We already defined that. Object name. Now this is the object name in Coppelia sim. So that is going to be whatever it is here, which is the sphere. I think I might have made a mistake. It should be in single quotes. Okay. And then the operation mode. This is something which we ask Coppelia manual to ask it what it is. And here the preferred one is blocking. So we take that. Sim dot blocking. So now we have the handle available as an object with the identifier sphere. So now we can take this, put the handle here, the parameter ID. Okay, so where is the parameter ID? So again, I need to search float parameters. Okay, so float parameters, the parameter value, and here is the list of all parameter values. So in this case, I need init velocity. So that's 3000, 3001, 3002. Like previously, you could also use this. Let's just use 3000. That's easier. So let's call it 3000. Okay, and then remember it's 0, 1, no 2. Okay, so we'll have that. Number of parameter values. So I need to again go here and check for float. So it should be set floating. Okay, so now we have parameter value. So what do we want that velocity to be? So I think it was, if I'm not mistaken, it is 1, 0, 1 for x, 0 for y, and 5 for z. So let me set that to 1. And then operation mode, which I need to again go here and find the operation. So this mode, you need to be one shot, which means that the data will be sent to Coppelia sim, but we will not wait for a response back from Coppelia sim that was assigned. Sim dot. Okay, so if this works fine, then the ball should move with a forward speed of 1, right? Shouldn't just drop down. So run this and that. Okay, there's a problem. Undefined get object handler. Okay, so this is line 23. And I think I forgot to put sim dot. Okay, we can maybe run this again. Okay, you see nothing happened. It really did not move. And the reason it did not move is because the way I did this. So I set gravity, I reset the dynamics, and then I put the velocity. That doesn't make sense. I need to first set the velocity and then reset the dynamics. So set the velocity, reset the dynamics, and let's see if this works. So stop, run, nothing's going, this is good. You can see it as a forward speed. Stop. Okay, so we can just keep doing this for each of those speeds, right? So take this, say B, and let's say C, and these values are 1, 2, 0, 5. Okay, so now stop, run. Oh, because this did not stop. That's interesting. Why did this happen? I thought the gravity would have been reset to 0. Maybe it didn't stop. Okay, we can debug it now next time. Okay, nothing is moving. So you see it jumped and then it ended. So now the gravity should be back to 0. That's good. So I had skilled this application before that. Now this is how you send velocity x, y, z. Okay, and in this case it's nice because you send the velocity, you reset the dynamics, and everything was ready for it to project. What if you had to set all these 3 parameters simultaneously? So for example, imagine there is a manipulator with 6 joints and you want to set the angles for those 6 joints. And if you set one angle and then next angle, next third angle, fourth angle, fifth angle, sixth angle, then there will be a possibility that there would be delay in assigning those velocities. So this is more for the threaded scripts, but I think I should tell you how to do this, which is how do you send all these commands, all these velocities simultaneously. So for that, we need to do what is known as pause communication. So let's see what this does. Flow it a little bit. Okay, so this allows to halt communication between sending threads. If you want to send several values to Coppelia sim and they should be valid at the same time. So this is like if you want to send 6 joint angles at the same time, but you can only send them one at a time through the command. Then then you need to pause the signal. So this is how it's run. You first pause communication. So you put client ID 1. So that's what we'll do here. In fact, we can do it for gravity too. So now we pause communication. We send this, all these calls, including this one, right, which basically is resetting the dynamics, and then we resume communication. So we just take this command and then say 0. Okay, so pause and then send a bunch of commands and put 0, which means that now all these 3 things are going to be executed at the same time. So this is just a better practice in running code than trying to send them individually. It will not change. In this case, it's not going to change anything. Interesting. Something was very different. Let me just, what's going on? Let's see. Thought it just jumped too high. Something is not looking right to me. It's not doing what it's supposed to do. So it looks like what happened was it sent these things and all these commands. It set gravity to 0, and then the initial speed showed up, which means that it just is going linearly. It's just going towards the moon, I guess. So I'm just going to stop this. And so this is something to do with the way I put this program here. I think that I should probably not have set. I think I should not have reset the gravity this way. I shouldn't reset the dynamics this way. I should send all these commands, then resume communication, and then reset the dynamics. This will fix it. Yeah, that's better. So reset dynamics is not, I shouldn't have called it. I should have set all the parameters, then reset dynamics, which is probably the right way to do it. Okay, so that took care of that. So this is setting up initial speed to what we want. Now we want to introduce the drag force. And the drag force, let me kill this. The drag force is something we set here. So what we did was we collected the velocity. And once we got the velocity, we found the XYZ velocity. We found the force in XYZ based on a formula. And then we put a force stock, and then we call sim add force stock. So the first step is to get velocity. So let's just get the velocity of the sphere. Okay, so for that, let's go to the API, get velocity. That's the joint velocity. We don't want that. Let's try velocity. I'm pretty sure there's a command like this. Okay, get object velocity. So turns out there are 2 velocities, and I think they're redundant. You see velocity in the regular API. There is get velocity, and then there is object velocity. Get object velocity. I believe they are essentially the same. I don't know why they've put both of those. You can check the documentation. Anyway, either of them will do its purpose here. So let's just use get object velocity. This is the syntax. Okay, it returns the linear velocity, angular velocity, client ID, object handle, no problem, sphere. Operation mode is supposed to be, it says simx op mode streaming first call and simx op mode buffer. So my understanding is that I needed to call it once, maybe initialize it, and then call it. When I call it multiple times, I need to call it with this sim op mode buffer. So let's just do that. Let me call it first here, where I'll say, let's just return code. Let's put the return code as 4 linear velocity. angular velocity. So I always need to say sim dot client ID, object handle, in this case it's the sphere, and then operation mode. Let's copy the streaming one. Okay, so this is not where I wanted. I actually wanted in the while loop because I need to add the drag force at every simulation step. So I'm going to copy paste it here. The only change I need to make is make the subsequent call. I need to call it through this mode buffer. Okay, so to check if it works, let's make it print. Let's say Vx is linear velocity 1, Vy is 2. I think this is not how MATLAB produces the data. Better. Okay, and then easy, and then we can just print it Vx, Vy, Vz. See if it's doing its thing. Okay, so run this, and now run that, and so you can see it's printing x, y, z. The y velocity doesn't change because we set it to 0. So this works fine. Okay, now we need to do our thing, which is set the force per this formula. So I'm just going to copy paste this. There's a drag force of 0.25. Just copy paste and modify it. So C is 0.25. We don't need the velocity. You already took those. The velocity magnitude is just square root of Vx squared. That's good. And the force is force Y, force Z. All looks good. And then I need to say that the force is Fx, Fy, Fc. Okay, and then the torque is obviously 0. So the torque equals 0. Okay, now I need to pass this back to Coppelia SM. So we have this add force stock. So clearly we need to find if there's an add force stock. Let's go here and try to search if there's an add force stock within the MATLAB API. So let's search, and then it's not there, which means that now we have to define our own add force stock by using sim call x script. Maybe I have defined it here. I can just search for it. Sim call x script function. Okay, we use that. So let's just copy this. So out floats, out strings. So are we going to is this function going to return anything? We are not going to return anything. We're just going to pass values, right? So we need client ID, script description, number, script handle, name. We'll call it user underscore add for stock, and we need to pass ints, floats, strings, buffer. In which case, in this case, we only need to pass floats, which is the forces, and if you need the torques also, the torques are 0. And then the operation mode for this is going to be blocking. Okay, so let's copy this. Okay, it's a long call. We just work on it like this. Okay, return code. Let's just what we have before. Let's call it 5. The out ends, you can keep them as it is. It's not going to return anything. Strings, we don't care. Buffer, we don't need that. Sim.sim complex. The client ID is client ID, so you don't have to worry about this. Script description. So this is going to be attached to the child script. So I just copy this. Oh no, so it's attached. Sorry, my bad. So attached to the sphere, it's called child script, and then I get to give it a name. So let me just copy everything here, paste it here. Function name. That's enough. Okay, so sphere, this isn't changed. Let's call it add for stock. So the name is kind of obvious. It reflects the. Okay, now the thing is, what is it inputting? Floats. Now, if I want to pass the force and torque, I only have one thing called infloat. So what I need to do is I have to basically infloats. I'll need to define it as fx, sorry, f and torque. So force and torque. Okay, so it passes all those 6 parameters. So now infloats stays as it is. The strings, I don't need to send anything. The in buffer, nothing. And then the operation mode, we can look at the manual. It says operation mode is Simex blocking. Okay, the long call. What we're missing now is we need to define this function inside Coppelia sim. So let's define this function. Okay, so this is half the work. So go here. Okay, so we have a call like this, which needs to be similar function. Okay, add for stock. Now we might want to see the syntax because I deleted the syntax from the earlier one. So let's see the syntax. If you click on here, maybe, yeah, this is how the syntax is in Coppelia sim. You can just copy this, it's the easiest. So copy this, put it here. Okay, so this is going to be my function. Okay, we don't have to change all this, but we just need to understand that infloats is going to be our, delete this. Infloats is what we have. So for the force, we need to get the first 3 values of infloats. 1, 2, 3. And then torque will be infloats 4, 5, 6. And the last thing we need to do is add for stock. So we just go to this command, copy that, paste it. So sphere, which you've already got for stock, this is fine. Okay, so I think it's all set. Let's see what happens now. There's an error. Expected line 8. Okay, line 8. Yeah, this should be a curly bracket. Run this again. Run this. Okay, so you can see the difference between what we got earlier without drag force. So if you put force equals 0, which is essentially a projectile in the free fall, no drag force, then you see this response. Jumps higher and goes all the way down. But if you change this to drag force, it jumps much shallower, and then it just doesn't quite go. Okay, so that is let's stop this. So that is how you take code which you want to write in Coppelia sim and write a part of it in MATLAB. Now, the only reason you might want to do this is so many of these things, you can see it's more work to do things in MATLAB. The only reason you might want to do this is you have some code with some functions in MATLAB which you spent a lot of time writing. You wrote like 300, 400, or 1,000 lines of code, and that code you'll have to take and port that in Lua, which is going to take a lot of time. So in that case, what you can do is you can basically take that part of the code and then uh, make MATLAB talk with the Coppelia sim, and you can basically get the functionality of MATLAB within Lua, within Coppelia sim by doing that. You could also potentially do things like So in this case, you can see that uh, I wrote everything in MATLAB, but it's possible for you to basically take this function and just write it in here. So you write part of the code in Coppelia sim, so everything here is still valid, and part of the code in there. We can try that actually. So in that case, we will not call this. So we can comment this whole thing up. Okay. So now when you run this, it just is going like the normal case. Okay, stop. Okay, I think I might have killed this, terminated, so the gravity would have been, yeah. Let me run this first. Okay, now it should be reset to 0. Okay, now what I'm going to do is over here, uncomment this part of the code. You need to set, uncomment this. Okay, this is all looking good to me. Okay, let's just run this now. Okay, nothing is moving, and now run this. So you see it's the same response we got by parting part of the code in MATLAB, part of the code in Coppelia. So either of these will work. So I think it's writing more code in MATLAB is just not a good idea. So even though I showed you how to write these functions in MATLAB, I recommend that you try to write minimum code in MATLAB and try to write most of the code in Coppelia Sim. That way, or Lua, that way you don't have to do more work and only write the code which you think is hard to port into Lua as the code which you want to write the wrong code. Projectile. Let's just see if this works now since I committed it. Yeah, it looks fine.